So continuing our conversation on the NumPy, let's start with the array-oriented programming with arrays, NumPy array, right? And let me load the library. And what I'm doing here is np.arrange is nothing but it will fetch the data with from -5 to 5 means these are the size of the matrix and it the difference between the point one all the points, right? So uh, all the arrangement is between these two variables. Now let's do a mesh grid. So mesh grid is take two-dimensional array and produce the pair. So in this I'm just using the both point and point and putting into x and yx. Right, let me show you that. And now we are calculating the square root. So it is nothing but square root of x square plus y square, right? Z and p dot square root is the function, the inbuilt function which we are using, x's and yx and z. And let's plot this. So to plot anything in the Python, we use matplotlib library. If you don't already have, just use the pip install matplotlib. I already have, so I'm not going to run this. And let's plot this. So what I'm doing, I'm importing the matplotlib library and using the mishow function with the z zeta or whatever we have calculated just now. And color mapping is the gray, right? And it will have the color bar in the title. So let me run this. So this is what the image plot for x square plus y square looks like for all the grid values of all the grid of values, right? Also, let's go to the expressing condition logic as the array operation. So what I mean by let's create three arrays x, y, and condition. So as you can see, the size is same. It has all the five elements, and let's if I want to based on this condition, I want to extract the data from either from x or y. So if it is true, then get this data, else get this. Right? This is what the condition says. If x is true, right, give me the x. If c is true, give me the x, else give me the y. And I'm just dipping these three sequences into one, right? So I got 1.1 because it is true, right? In this it is true, and this is true. Else false for this one. Now same thing you can do in in NumPy using np.where. So what happens is check the condition. If it is true, it is goes to x. Else it goes to y. Same output with one line of code, and without doing the for loop. So let's get the matrix of 4 by 4 from the standard normal, and we can check with which element is greater than 0. So in this case, this is greater than 0, this is greater than 0, and it will give you the Boolean matrix of true and false where the value is greater than 0. And what you can do, you can also change the values based on this condition. If value is greater than 0, then make it 2, else make it -2. It did not change because we are doing the operation on the copy. Right? It's copied the new created a new matrix. The original one is correct, same. And again, you can use the matrix itself. So if it is greater than 0, make it 2, else make it keep whatever the value is present. Now let's talk about the mathematical and statistical method. So in this, let's create the 5 by 4 matrix, right? And I want to see the mean of this. So in the statistical mean is nothing but it will get mean of full matrix, right? And you can use AIR dot mean function or you can use the NumPy NP dot mean for the same purpose. It will give you the same result. You can get this sum, right? Sum of all these and full matrix. Yeah, or you can use NP dot sum passing the matrix in the argument. What is interesting, let's say you want to get the sum of these rows only, right? So rows, it you have to use axis 0 and for column you have to use axis 1. So just pass this additional argument x is 1 if you want to get the summation or mean or any other statistical operation like this. So it is for the columns, it is for the rows. Cumulative product is nothing but what it will do, it will sum, right? Like it will keep adding this one, this one, this one, and this one like this. So let me, if it's very just difficult to calculate, means let's create a new matrix, right? 1 to 0 to 8. And if we do the x cumulative sum by the x is 0, 0 always mean rows. So it will sum like this, right? 0, 0 plus 3, 3, 3 plus 6 equals to 9. And instead of summation, if you want to do the product, you can use the cum prod, right? And it will 0 multiplied by 3, 0, 0 multiplied by 6, 0, right? So we have a 0, 0, 0 in the first row. Now let's talk about the method for the Boolean array. So we let's create the 100 element array, right? Mm, And we can have, if it is greater than 0, make it sum, right? How many elements are there? 56. Less than 0, 44. There are other two inbuilt functions, any and all. Any means it will check with for if any of the value mismatching your condition. All it will check whether all the elements are matching your condition, right? So Boolean, let's create this array. So whether if any of this true, it will return true. If all these are true, it will return false because we have a two false here, right? You can use the sorting uh, NP. Let's create a 8 element array, right? And you can sort using the sort functionality. Also, you can use the unique. Unique is nothing, it will remove the duplicate like distinct in the SQL or in the base Python we have a set. So if you do a set and the values, it will remove all the duplicate values, right? So if it is unique, so the Bob will Joe, it will not repeat again. Linear algebra, the very vast topic in mathematics and in programming too. But there are many inbuilt functions available already. You don't have to do the calculation, and you can use the inbuilt function of NumPy or base Python to do this. So we'll use the NumPy in this case. So let's create two matrices, right? X and this is Y, and I want to do the dot product of this. So I can use X dot Y, so it will be dot product of two arrays, or you can use NP dot XY, or you can use the at the rate function between these uh, two arrays and it will result the same output. So s- different way to do the same thing. There is a library uh, in built in the NumPy which called ALG, linear algebra, and we are importing here inverse and quadrant to do the operation on the matrix. Let's create a 5 by 5, and I want to multiply, right? I want to first take the transpose of x and multiply with x, right? And if I want to do the inverse, I use the inv function and it will create the inverse of the matrix. And I can multiply this mat and the inverse, right? I should get 1 at the diagonal. And let me show you the one example of random walk which you might have heard. It nothing but by taking the probability of what is the next step, it will add the new value. So let's take the example of how we can do in the base Python. So I'm importing the random module here. Position starting position is 0 and walk means all it start with 0 and every step will be added here. We are taking 1000 step and I'm just iterating over this 1000 step. If the rand dot int mean if it is 0, right? Uh, then if it is it will take a value, and if step is equals to 0, else it equals to 1. So 1 or minus 1 will the two values which will be adding into the position, right? And the whatever value we are getting, we are just appending this. So let's run this, and if you plot this, you will see. So value is either going to 0, 1, 1, 1, 1, 1, minus 1, 0, 1, like this. In the NumPy, what you can do, you can use the again the random library in the random function in the library, NumPy library, and I'm just setting the seed 1 2 4 5 just to get the random new numbers, and the integer is 0 to 2, and steps is thousand. Let me make it 1000. And if it is a flip of coin, if it is draw, then the value is 1, else value will be minus 1. I'm just doing the cumulative uh, s- sum of all the value which I'm getting here. So next one is just I'm taking the checking the what is the minimum value, what is the maximum value, and plotting the same thing here. So all the thousand values like this. So if I do again, right? If this change it, see it is changing. Yeah, that's for with this we conclude with the NumPy. Next we'll start looking into the basic of pandas, which is very important. The most of the series will be based on mostly on the pandas, and then we'll also include the NumPy here and there. Thank you.